I found this visualization online on a website called ShaderToy. It's mesmerizing, and the cool thing about ShaderToy is that the code for everything is right there next to the visualization. I wanted to understand what was going on. What is this twisting, ever-changing shape? To set things up, I made a new ShaderToy visualization that kinda mimics the original, but allows me to deconstruct the painted picture into its layers. Okay, here we go. We're traveling forward in space in this fractal, which right now has a couple of interesting filters that make it appear to be infinite, and also crazier than it really is. First, there's a filter that's warping the space. If we were traveling through a three-dimensional grid, it would look something like this. This is neat, but there's something definitely wrong. These lines aren't straight at all. They're quite curved. The reason is that there is a warp that changes the space that we're rendering in. Let's turn that off. Okay, let's do that again, but this time with the fractal. Alright, things mostly look the same at this point, but they're a little less trippy. The next step is to remove the mirroring effect that makes this fractal infinite. Okay, what are we left with here? This is a Menger sponge, but not a normal one. Let's bring it back to what it classically looks like. A Menger sponge is a cube with a bunch of holes taken out of it. Let's get rid of all of those and then explain how they're added. We start off with a blank cube, and then we subtract a 3D cross from it. The cross's inner width is 1/3 of the cube's size. This sort of creates like a Rubik's Cube, a 3x3 subdivision of a cube, with the cross removed. We take those outer pieces of this Rubik's Cube-like thing, and we remove another cross from each one of those. We keep repeating this process, and before long, we've got something that looks quite like a Menger sponge. Because it is a Menger sponge. Let's talk a bit about Raymarching, the way that this thing is actually getting rendered. Raymarching is a method of rendering where you don't know anything about what you're drawing other than how far its closest point is from you. You get no information about what direction the closest point is, only the distance from any provided coordinates. The method's name, Raymarching, is actually fairly descriptive to how it works. Starting at the location of our virtual camera, we create a ray for every pixel on our screen. Each ray will travel toward our virtual world in a straight line at a slightly different starting angle, depending on how far from the center of the camera image that pixel is. In this simplified 2D version, we can pick the angle that a single ray starts at. In this example, we march forward until we get really close to what we're rendering, or we get bored of marching forward. Usually, we only march forward a certain number of times before giving up. In our case, we take 60 steps before we just say, screw it, there's nothing in front of me. Each step's length is determined by the distance function, the thing that tells you how far you are from the object. The first step the ray takes at the camera origin, we ask, how far away is the thing we're rendering? And then, we go that far forward. In all likelihood, we marched in a different direction than the closest part of the thing, but that's okay. We just repeat that process, sampling the distance to the thing, and then marching that far forward. If all goes well, we'll find ourselves getting pretty close to the thing that we're rendering. Depending on what we're rendering, we have different definitions of pretty close, but at some point we just say, okay, we're done, we found the thing that we're rendering. I won't go into specifics on how we take this found distance from the camera and turn it into a nice pretty color, but that's okay, you'll live. If that didn't make sense the first time, take a look at how the ray's path might change in the scene if we change its angle. Sometimes, our marching forward in smaller steps doesn't seem to help us. We could have spent our time better by just speeding past those areas, but we didn't know that. That's the problem with Raymarching. We sometimes spend all of our time tiptoeing near the thing we're rendering, and sometimes we met things further away, because we took 60 steps already. And with that, let's rebuild the visualization and see how it looks. Thanks for watching.